In this video we will be graphing the secant function. Now remember that secant is the reciprocal of the cosine function. So I'm really going to start out by graphing the cosine function and then using that as a guide. But also, when you see x over 2 like this, please understand that this is the same thing as 1/2 x. So this is like having 1/2 x plus pi over 4. Alright, sometimes it helps to put a little 1 right there. So when I pull out this 1/2 outside of parentheses, which I must do, then I need to divide pi over 4 by 1/2. So how do I do that? Alright, so pi over 4 divided by 1/2, you multiply by the reciprocal. So that's pi over 4 times 2 over 1. So that's going to be 2 pi over 4. So that's going to be pi over 2. So that is what is going to go right here. Okay, so now I'm just going to sort of recopy all that over here. So like I said, I'm going to have 1/2 and then x plus pi over 2. And then all of that should be inside of another parentheses. So I'll have parentheses inside of parentheses with the secant out front. And then there's this a value of 1/2, so let's get that going. And y equals all that. So this is the version I'm going to be staring at as I do the rest of this problem. Let me just erase some of this nonsense. Please stand by. This train is departing. Okay. So now I need to deal with the fact that this is the a value. Okay, that's going to affect the amplitude of the cosine function. This is the b value. That's going to affect the period. This is the h value, which is going to affect the phase shift. Okay, so we need to find the period, which will be affected by the b value. So the period is going to be the normal period divided by the b value. And remember, I'm really looking at the cosine right now, and I know that the normal period is 2 pi, so I'm going to do 2 pi divided by the b value. Alright, and when you do this, when you divide by a fraction, you multiply it by the reciprocal. So that's why the period is going to be 4 pi. Okay, so I'm going to have 4 pi right here. We'll deal with the x-intercepts and asymptotes later. Phase shift. We have an h value, so there's going to be a phase shift. It's going to be the opposite direction of what it looks like right here. So it will be negative pi over 2, which will be to the left. Now, so as I first graph the cosine function, lightly and dotted to use as a guide, normally we start at 0 because the cosine function normally starts at 0. It starts up high, but it starts at 0, and then we go from there. But because the phase shift is pi over 2 to the left, negative pi over 2, then that's where I'm going to start. So I'm going to start at negative pi over 2, which I'm going to put right here. So negative pi over 2. So I know that the cosine function is going to start here. Now it's going to start high like it always does, but it's going to start here where it has been shifted to. Now, if I look at this as the beginning of the period, every one of these marks is 1/4 of the period. So if I count over 1, 2, 3, 4, this is where the period should end. So I need to find the values, the x values of each one of these positions. So what I like to do whenever there's a phase shift, I know that every one of these marks is 1/4 of the period. All right, you can see there's 4 of them. 1, 2, 3, 4. It's 1/4 of the period. So I like to calculate what is a quarter period. I really only do this when there's a phase shift. But when there is a phase shift, I find this very useful. So what is a quarter period? Well, this is going to be straightforward. So the period is 4 pi. So a quarter period is going to be 1/4 of 4 pi, which is just going to be pi. So that means each one of these positions should be increasing by pi. So that means I really need to add pi to this, but I need like denominators. So this would be the same as adding 2 pi over 2. Can you see that 2 pi over 2 is the same thing as pi? So I'm adding pi, but I'm going to think 2 pi over 2 when I do it. Okay, so if I take this is like having -1 pi over 2, and now I'm going to add 2 pi over 2. -1 plus 2 is +1. So this is going to be +1 pi over 2. If I add 2 to that, that's going to be 3 pi over 2. 2 more is going to be 5 pi over 2. And 2 more will be 7 pi over 2. And I know that's where it ends. Now I always put these numbers down low in case I need to reduce. But turns out none of these needed to be reduced. Okay, so I feel silly, but it was still worth it because sometimes it's useful. But in this particular case, I'm just going to recopy them. So I got pi over 2, I've got 3 pi over 2, I've got 5 pi over 2, and I've got 7 pi over 2. Alright, let me erase all this gibberish, so we don't need it anymore. Okay, I already see where the y-axis is going to be. The y-axis is always at 0, but even though I don't see 0, I know that it will be between this negative number and this positive number. If I didn't have any negative numbers, I would have kept going until I got a negative number, just so I could see where the y-axis is. Alright, but the y-axis will be right here, so we'll go ahead and just put the y-axis here between these two numbers. Now, let me go ahead and mention the a value. The a value is 1/2. So, you know what, I'm going to make these numbers pretty big, I guess, because I don't want my graph to be too squished. So I'm going to put 1. Well, you know what? I changed my mind. I can just put a mark where I normally do and just call it 1/2. Nobody can stop me. It's not illegal. Alright, so that makes this mark down here -1/2. I'm just going to do it that way. Yeah, that way. So the cosine function always starts off high, as you know. So, but not on the y-axis though. I almost kind of did it wrong. It's going to start here at the phase shift. So it's going to start off high right here, and then it's going to fall to the midline. Don't be distracted by the y-axis. That's not really part of this. And then it's going to fall to its lowest value here at 3 pi over 2. And it'll go back to the midline at 5 pi over 2. And it'll be back to its highest value at 7 pi over 2. So those are the 5 values of cosine, our key values. So I'm just going to lightly put the cosine in as a dotted type situation. Okay, very lightly and dotted. Because I'm really just using this as a guide. Don't forget that we are graphing secant, the reciprocal of this. Now, because we are graphing secant, which is 1 over cosine, anywhere that cosine is 0, it's going to be undefined, so you're going to have an asymptote. Okay, anywhere that cosine is 0. So I'm looking at you, x-intercepts. Alright, so I should have vertical asymptotes in these two positions where I have my x-intercepts. So this is where the cosine is 0. So let's go. Alright, I got a vertical asymptote here. And another vertical asymptote here. Okay, so the cosecant function is going to be the same as the cosine at the highs and lows, like these 3 points that I just drew. And then from there, you simply approach the asymptotes, the vertical asymptotes. Alright, so this is going to approach the vertical asymptote like this. Alright, this is going to approach the vertical asymptotes like this. And this is going to approach the vertical asymptote like this. Alright, so there you go. That's one period of the secant function. Alright, we need to talk about x-intercepts. So the x-intercepts, there are none. Alright, don't look at this green or pink stuff. The cosecant function is just the blue. Alright, the solid lines. And notice that none of that touches the x-axis. So none. Vertical asymptotes. Okay, notice that the vertical asymptotes occur every half period. See how there's only 2 marks between here, and every mark is a quarter of a period? This is half of a period between here and here. So I usually just pick my first positive one. So here's my first positive vertical asymptote is at x equals pi over 2. And you have to write the x equals part. Alright, but to capture the many vertical asymptotes, because they occur every half period, then I can add multiples of a half period. Well, the period is 4 pi, so a half period is 2 pi. So I will say 2 plus 2 pi n, where n is an integer. Okay, now that was finished quickly enough that I'm going to go ahead and try to squeeze in problem number 5. Cotangent. Cotangent is the reciprocal of the tangent function. So what am I trying to say? So cotangent is 1 over the tangent function. So just keep that in the back of your mind. I'm not actually going to graph the tangent function, but it's just something to think about. Now, I need to factor out this 1/3 before I get too carried away. So if I take out this 1/3, alright, you have to always bring that b value outside of the parentheses. To find out what goes next, I need to divide pi over 3 by 1/3. So let's look at that. Pi over 3 divided by 1/3. You multiply by the reciprocal, so that's pi over 3 times 3 over 1. 3's cancel out basically, so you're just going to have pi. So this is just going to be x minus pi. Okay, so all of that really should be in parentheses. And then I've got my cotangent and my -3 and my y equals out there. So I think I'm just going to go ahead and erase this nonsense. Okay, so I have wait, here's something special. This is going to be a reflection. Okay, a reflection over the x-axis. But at any rate, this is also the a value. So that's going to affect the graph, the stretch of it. Though it is not the amplitude, cotangent, like tangent, goes up and down forever, so there is no amplitude. But I digress. This is the b value, which will affect the period, and this is the h value, which is a phase shift. So let's talk about the period for a quick second. The period is always the normal period divided by the b value. For cotangent and tangent, the normal period is pi. So we're going to do pi divided by this b value of 1/3. So when you divide by a fraction, you multiply by the reciprocal. So this will be times 3, which is just 3 pi. So the period is 3 pi. We'll talk about the x-intercepts and the asymptotes later. The phase shift is this h value. It's the opposite of what you see here as far as the sign. So this is going to be a positive pi. So that's to the right. Okay. Now, when we think about how we graph tangent, first of all, we always graph 2 periods of tangent. And we usually start right in the middle. All right, you know, the first period of tangent, we usually start right at 0 because we know there will be a point there. Now we're going to do the same thing for cotangent as far as starting in the middle. However, we're not going to put 0 in the middle because of the phase shift. All right, there's a phase shift of pi to the right, positive pi. So that's what I'm going to actually put right in the middle, is going to be pi. Alright, I always start at the phase shift. Now, if this were a tangent function, I would know that there would be a point there. And if I went 4 to the right, that would be the point that ended the period. So 1, 2, 3, 4. So normally I would say this. However, now I know that since I'm doing cotangent, alright, that's the reciprocal of tangent, so these points will not be intercepts. Instead, they will be asymptotes, because this is where tangent is 0. And if tangent is 0, then 1 over 0 is undefined, so that's an asymptote. So instead of points here, the way we have for tangent, we will have asymptotes here for cotangent. Okay, so that's what I'm going to do. So I'm going to have asymptote here. Okay, later I'll draw it down here, but it's going to be in my way. So 1, 2, 3, 4. So like I said, this point that used to be an intercept, I now know is an asymptote. Now, however, whereas the tangent function has an asymptote right in the middle of the period, cotangent is just the opposite. We have learned that instead of an asymptote, right in the middle, there's going to be an intercept. Alright, so that's going to be a point that's on this line. So this would be 1 period to the right. If I do the same thing to the left, so if I go to the left 4, 1, 2, 3, 4, that's a full period, so I should have another vertical asymptote. And right in the middle, again, I should have another intercept. Alright, so what I really need to do now is label these numbers. Alright, all the way to these green asymptotes on the end. So the way I like to do that when there's a phase shift, Since every one of these marks is a quarter period, I like to figure out what is a quarter period. Question mark. Well, the period is 3 pi. So that means a quarter period is 1/4 of 3 pi. That means a quarter period is 3 pi over 4. That means every one of these marks should be going up by 3 pi over 4. So I am going to add 3 pi over 4. Okay, now how do I add 3 pi over 4 to pi? Well, it would be helpful if I had like denominators. Pi is the same thing as 4 pi over 4. So I'll look at it that way so I can do like denominators. So now if I add 3 pi over 4 to 4 pi over 4, I get 7 pi over 4. So in my next spot, I will have 7 pi over 4. Alright, 3 more and I have 10 pi over 4. 3 more and I have 13 pi over 4. 3 more and I have 16 pi over 4. Alright, let's do the same thing going to the left. If I go to the left, I will be decreasing or subtracting 3 pi over 4. So if I subtract 3, I will have 1 pi over 4. If I subtract 3 again, I will have negative 2 pi over 4. Subtract 3 again, and I will have negative 5 pi over 4. And subtract 3 one more time, and I have negative 8 pi over 4. So I put all these numbers down low because I knew some of them would need to be reduced. So I'm just going to go through and reduce everything that needs to be reduced. Let's see, 7 pi over 4 does not reduce. 10 pi over 4 is 5 pi over 2. 13 pi over 4 can't be reduced. 16 pi over 4 is 4 pi. Pi over 4 cannot be reduced. Negative 2 pi over 4 is negative pi over 2. Negative 5 pi over 4 cannot be reduced. And negative 8 pi over 4 is negative 2 pi. Alright, I can erase all this pink stuff now because I'm done with it. Okay, and that leaves me space to extend my vertical asymptotes. Alright, which go both directions, of course. Alright, we're ready to do this graph. Well, you know what? We're missing one thing. Now we need the y-axis, mostly so I can mark off the a value. So where's the y-axis? The y-axis is always at 0. I don't see 0, but I see a negative and a positive. So I know that the y-axis will be in between these two. So that's what I'm going to do. I'm just going to put the y-axis in between these two numbers. Alright, so there's my y-axis. Let's see, let's check out that a value. What's going on there? The a value is negative 3. So focusing on the 3 for a minute. Alright, I'm going to go up a little bit and call this 3. I'm going to go down a little bit and call this negative 3. Man, there's not really space for it, but that's negative 3 up there. Okay, now we are graphing cotangent. Now, the tangent function is always increasing, and we know that everything about the cotangent is backwards. So since the tangent function is always increasing, the cotangent function is always decreasing. But this is not a normal cotangent function. Because of the negative sign, this is going to be a reflection. So instead of decreasing like a cotangent function normally does, it will actually be back to increasing again. So I know that's a little confusing, but tangent is normally increasing, so cotangent is decreasing. But it's a reflection, so this cotangent will actually be increasing. So with that in mind, I'm going to take my values and I'm going to be increasing. So I could start from this intercept, for example, and increase as I approach the asymptote. I'm going to be mindful of the a value though, so if I go halfway, it should be at the a value. So I'm going to be increasing, but I'm going to try to hit that value as I do it. And then I'm going to do the same thing on the left. Alright, it's still increasing. Alright, from left to right, this is still increasing. At the halfway point, it should be at the negative a value. So when I draw it, I'm going to try to hit that. Okay, and I'll do the same thing over here. Now again, this should be increasing, so it should be going like that. But at this halfway point, it should be at the a value. So as I do this increasing bee's nest, I'm going to try to hit that mark. And I'm going to do the same thing over here as on the left. Now this is still increasing. From left to right, it is increasing. But at this little halfway point, it should be at this negative a value. So I'm going to try to hit that as I go. Alright, and there you go. That's what 2 periods of this cotangent function looks like. Alright, notice normally the cotangent function is decreasing. Alright, it should be going downhill from left to right. The only reason why it's not is because of the reflection. I actually ended the video, but I forgot about the x-intercepts. So, x-intercepts. Remember, this is 2 periods of the function. So if you just look at one period, like this one over here on the right, it only has one x-intercept per period. Okay, so I'm going to just pick my first positive x-intercept, which is 5 pi over 2. And I'm going to start with that. So the x-intercept is at 5 pi over 2. Now, as it repeats, I will have many more, but only one per period. So it's going to be multiples of the period. So I'm going to say 3 pi n. N is an integer. Okay, vertical asymptotes. Alright, vertical asymptotes only occur once per period. You have to go a whole period before you see one again. My first positive asymptote is at pi, so I'm just going to start with that. So a vertical asymptote, you always say x equals, because it's a vertical line, so x equals pi. And then I will add multiples of the period, so I will add 3 pi n again. Alright, where again n is an integer. Now I'm done with problem number 5.